Thank you for attending our presentation. My name is Yusuke Hirota, and I am a PhD student at Osaka University. I will introduce our paper, Gender and Racial Bias in Visual Question Answering Datasets. The so-called vision language tasks, which consist of applications that interact, process, and make decisions based on visual and language content, are one of the biggest challenges in modern machine learning research. Such tasks include image captioning, which aims to generate a caption to describe the contents of an image, and visual question answering, which aims to answer questions about images. And many models to solve these tasks have been proposed so far. One of the important issues of adopting such models into real-world products is how data represents the real world. A recurrent problem is that minoritized groups in non-Western cultures tend to be underrepresented in datasets. For example, although all these images are from weddings, the right one is not annotated as such because it doesn't align with the standard type of Western wedding. When minoritized groups are underrepresented in datasets, trained models can perpetuate social discrimination by producing potentially harmful outcomes. This has been the case in many applications, including vision language. For example, image captioning models can predict a wrong gender or cultural world by learning stereotypes in datasets. To raise awareness and start an open discussion, we investigate societal bias in visual question answering, VQA in short, one of the fundamental tasks in the visual and language community. The aim of VQA is to correctly answer questions about a given image, and it's used as a benchmark for visual and language comprehension. One of the current challenges in VQA is language bias. That is, the models exploit the superficial correlations between the questions and the answers in the training set. For instance, if most bananas color is yellow in the training set, questions about the color of bananas are answered with yellow even if the banana in the image is green. If societal bias such as sexism and racism is present in the training data, this problem may be causing VQA models to learn harmful stereotypes. For this reason, we investigate gender and racial bias in VQA datasets. To do so with a rule-based approach, we first select samples from 5 different datasets that mention gender, race, or ethnicity in their questions or answers. Then, we analyze gender or racial bias by comparing the difference between the subset. Specifically, we run statistics on the number of samples, analyze trends in the answers, and visually inspect for potential harmful data. Let's first talk about gender bias through 4 main points. Our gender analysis is conducted over the dataset annotations, which represent annotators' perceived binary gender and not gender identity. With a rule-based approach, we classify samples into women or men categories based on the gender words in the questions. For example, the question, "What is she holding?" is classified as women questions because it contains a women-related word, she. Then we compare the ratios of women and men questions in 5 standard VQA datasets. Here, there are the ratios of women and men questions for each dataset. We found that the number of questions about men is about double of women in all datasets. Next, we check the frequency of answers according to each gender. Unless otherwise stated, we will show the results on the VQA 2.0 dataset from now on, but similar conclusions can be extracted from the other datasets. Here are the top 20 most frequent answers in women questions. We highlight answers that appear only in one of the gender's top 20 answers. We can see traditional gender stereotype of women, such as pink, purple, and blonde. The top 20 answers for men questions show a strong association between men and sports, perpetuating the stereotype that sports is an activity predominantly masculine. Next, we focus on the questions that start with "What is this?" and conduct the same statistics as before. The woman's top 20 frequent answer distribution for "What is this?" questions show that women tend to be associated with motionless words like phone, sitting, and umbrella. On the other hand, men are mostly associated with sports. In the next experiment, we calculate the correlation between answers and women or men questions with this equation. The result of the equation Bs represents the degree to an answer is biased regarding men questions. Specifically, if Bs is close to 1, then the answer is correlated with men questions, and if it's close to -1, then the answer is correlated with women. We first show the top 20 answers that are correlated with women questions. We can see that there are no sports or activity-related words. Looking at the answers skewed toward men questions, we find that there are many sports or activity-related answers reflecting the real-world stereotypes. Aside from the statistics, we manually explore each dataset for potentially sexist or harmful samples. Through the exploration, we find two types of problematic samples. The first one is gender-stereotypical answers. In the left example, to the question about the topic of the conversation between the two women, which can't be inferred using visual clues, some annotators provided gender-stereotypical answers such as men, hair, and shopping, probably based on their own prejudices about women. A similar case can be found in the right example, which shows the stereotypes about men. The second type of biased sample is harmful samples that have a sexual connotation. For example, the middle sample's question has a sexual connotation about a woman in the image. These gender-stereotypical samples tend to appear when the questions can't be visually grounded. Let's move on to the analysis of racial bias. To study racial bias, we identify samples in the dataset with reference to race or ethnicity. Similar to the gender analysis, this is based on annotators' perceived race or ethnicity. Concretely, we select all the samples whose questions contain the words race or ethnicity. We refer to these samples as racial samples or racial questions. First, we investigate the distribution of answers to racial questions. We show the top 10 answers to racial questions in VQA 2.0. We can see that white people are the majority and black people are the minority. Concretely, white or Caucasian appears about 3.5 times more frequently than black or African. We next explore the relationship between race and nationality in the VQA 2.0 dataset. Specifically, we count the co-occurrence of racial-related and nationality-related words in the answers. For instance, in the answers to this racial question, Asian is a racial-related answer, and Chinese and Japanese are the nationality-related answers. Also, we roughly categorize racial-related words into 3 races or ethnicities: African-oriented with the words Black and African, Asian-oriented with the words Asian and Oriental, and White-oriented with the words White and Caucasian. We show the nationality-related answer distributions co-occurring with each racial category. As for the nationality words co-occurring with the African-oriented race, we can see that the African-oriented race is strongly tied to American. As for the Asian-oriented category, most of the nationality answers are Chinese. Regarding the white-oriented category, American is the most frequent nationality answer. It is remarkable to note that the relationship between race and nationality seems to be rooted in a United States point of view where white and black people are associated with American nationality and Asian people with Chinese nationality. This is probably the result of a US-centric annotation process. Finally, we manually inspect all the racial samples for all the datasets. In addition to this, we conduct an intersectional analysis and explore samples of women and men questions for each dataset in terms of racial bias. We find that there are two types of samples with racial bias. The first one is racial discriminatory samples. In this example, the question, what causes the skinning pigment of the girl in the blue shirt to be so dark, implies that lighter skin is the standard. The other type of sample is the biased judgment of race and nationality. For example, in the middle image, the answer is white to the question asking the race of the person, even though we can only see the tips of the fingers. A similar case can be seen in the right example. Such samples often appear in questions that are not visually grounded. In order to reduce the risks associated with gender and racial bias, we discuss possible solutions. We have shown that the VQA datasets have distributional bias related to gender and race. Training models without taking measures against the biased distributions can cause models to amplify societal bias in datasets. So, we encourage the users of the datasets to be aware of the distributional biases related to gender and race in VQA datasets and design models and training paradigms that can address these issues. The other problem is harmful samples that exhibit gender or racial stereotypes. Such samples are often found when the question is unanswerable from the image content. The ideal solution is to remove harmful samples by conducting manual filtering, but the cost of such a process can be extremely expensive. So we propose three alternative solutions. The first one is automatic screening to remove not visually grounded questions. The second proposed solution is to incorporate ethical instruction in the datasets annotation process. Please note that ethical instructions are not commonly provided to annotators when creating VQA datasets. The last solution is to create a platform to report potential ethical problems and review them to decide whether they should be removed. The main takeaways of our work are as follows. We showed that the answer distribution is very skewed concerning gender or race. Also, harmful samples denoting annotators' gender or racial stereotypes exist in VQA dataset. Those samples tend to appear when a question cannot be visually grounded. We hope to raise awareness and encourage the community to take measures to mitigate societal bias. So, thank you all for listening. If you're interested, please also check our work on bias in image captioning models, which is presented at CVPR this year. We are looking forward to your questions in the Q&A session, and feel free to reach out with additional questions outside of the session. Thank you.